We'll see. We'll talk about the net force in a few minutes. If you guys want to jot this down, you can. I'm going to post them to Schoology right away. It's entirely up to you. I'd hoped that I was going to give you this handout today, but I don't think that's going to happen. So let's talk about the net force. Now, net force, we did in grade 11. It simply means the sum of all forces. So in the expression, and please don't write everything down. In the expression F equals ma, the A can be interpreted as the total resultant acceleration which a body receives when acted upon by some total force whose magnitude and direction are given by F. So the A is what you see, the resultant acceleration, right? It's the resultant. It's what you see, what you observe, okay? And that is created by the net force. Since force is a vector quantity, the total force acting upon an object is the vector sum of these separate forces, and we call that simply, the net force. The net force is simply the vector sum. So F net is F1 plus F2 plus F3 plus F4 plus however many forces you've got. Okay, there is no formula for net force. It's simply add up all the forces. That's what it is. Right? I mean, that's more or less a review from grade 11. Nothing particularly new there. Okay, so here's Johnny and Billy playing tug of war. Each one's pulling with 75 newtons. What's the net force?
0.
Clearly it's 0. Is the object moving?
No.
No. Well, not unless it was already. Right? But if it was initially at rest, then that box or whatever it is, that crate they're playing tug of war over, is 0. The net force is 0, therefore acceleration is 0. Right? When the net force is 0, the acceleration must be 0. Okay, this time Johnny and Bill are pulling on sled. Each one's pulling with 75 newtons. Now we're going to add them together, same as before, except one's not negative. We've got a net force of 150 newtons. Whoops. Got a net force of 150 newtons. Is there going to be an acceleration? Yeah, but I can't figure it out until I know the mass. Right? Now, usually in real life, we have to deal with friction, right? In real situations, friction is often a force that reduces the net force, or reduces, I shouldn't say reduces the net force, reduces the applied force, right? The applied force is reduced, right? So we get the formula that you guys have used before, F net is equal to FA plus FF. This is simply F net equals F1 plus F2 plus however many forces there are. It just happens to be, in this case, there's only 2 forces, and they're labeled FA and FF. It's not different, right? It's just force 1 plus force 2. That's all it is. Now, remember that friction force, like all force, is a vector, so it being in the opposite direction has a negative sign associated with it. So more correctly, because some of you said, shouldn't you subtract friction, Mr. Bennett? It's really F net is equal to FA plus FF, but FF is negative. So in reality, you subtract the friction force, but because force is a vector, it's got a negative. The add simply means vector addition, is what I'm really saying, right? That's what I'm getting at here. Okay, so let's try one here. Simple one from grade 11. Suppose a 10-kilogram object is being accelerated by a 10-newton force. The force of friction is 6 newtons. What is the resultant acceleration? I'll pause there for a second. Let you guys. Okay, so the first thing we need to find is, before we can get the resultant acceleration, I need the net force. So F net is equal to FA plus FF. The applied force is 10 plus minus 6. My net force is 4 newtons. And now I can go F net is equal to MA. 4 newtons, 10 kilograms, A equals 4 over 10, or 0.4 meters per second squared. Pretty easy, right? Yep, second squared. Now, I'd like to point out in grade 11, when I show you stuff like that, you go, oh, you all freak out. No, this is so hard. Clearly, you've come a long way since then.
Can we derive some of these formulas?
F equals MA. Newton did that for us.
Oh.
Try this one.
That was not done right now.
Oh, I'm sorry. Let's try example 2. A 3 kilogram object is going 5 meters per second at t is equal to 0 seconds. 4 seconds later, it's traveling at 2 meters per second. What force of friction is acting? We are solving for FF. Quickly here. We've got an initial velocity of 5. We have a final velocity of 2, right? What force of friction is acting? I need to find my acceleration first, don't I? Okay, so Megan, I'm going to go VF equals VI plus AT. Final velocity is 2. Initial velocity is 5. I'm going to solve for my acceleration, and that's a 4. So my acceleration is going to be 2 minus 5 all over 4, which is minus 0.75. Am I right? Now I'm going to go F net equals MA. I've got a mass of 3. My acceleration is minus 0.75, giving me an overall net force of 3 times 3/4 is 9/4, which is 2.25, right? No?
Yeah.
And now
in the office, please, to
F net is equal to FA plus FF. I'm pretty sure you guys can finish this on your own. The applied force was, guess what? That's right, there was no applied force. Therefore, what I really need to say is friction force is the net force minus 2.25. It was easier than I realized.
Awesome.
There you go.
Have a good weekend.
Have a great weekend. There is school on Monday.
No worries.